There is the front flipper, a hand built on the same model as my own hand.
Biologists define homology as similarity in structure between different organisms.
Now this has the same design exactly as your arm. There's the upper arm.
My textbook
one bone.
would show the forelimb, a hand, and it would show a bat's wing and a whale's flipper, and say because they have similar structure, have similar bone pattern, that they must share a common ancestor.
And then the 5 very long fingers, just like yours.
Homology was something that biologists discovered long before Darwin. Aristotle knew about homology. The real question about homology is, how do we explain it?
There are plenty of examples of homological structures in biology which are obviously not based on common descent. For example, take the Australian wolf, which, except for the reproductive system, features a wide variety of organ systems that are absolutely homological to the North American timber wolf. But there's no evidence that these homological structures arose because some wolf at some time in the past, or some proto-wolf, decided first to migrate to Australia and then to migrate to North America. The evolutionary lines are completely distinct, and yet we see a profound degree of homology. We see this throughout the animal kingdom.
The mere pattern of the bones doesn't tell you how it happened. You have to supply a mechanism to explain how it got that way. Well, Darwin's mechanism, as understood by modern Darwinists, was genetic. You inherited similar genes, and these genes made the bones grow the way they do. The problem is that the evidence doesn't fit that explanation.
According to modern Darwinism, if two structures are similar because of common ancestry, each structure should be produced by similar genes and go through a similar pattern of development in the embryo. But contrary to these predictions, biologists are learning that homologous structures can be produced by different genes and follow different patterns of development. For example, biologists consider the body segments of fruit flies and wasps as homologous. Darwinism predicts that these similarities should be due to the same gene, but in fact, different genes account for the development of body segments in these insects. This contradicts the idea that homology must point to common ancestry. In the same way, many body structures considered homologous by biologists develop in embryos in fundamentally different ways. One example is the gut in vertebrates.
If the Darwinian theory were correct, the process by which the gut is constructed should itself be homologous. In fact, this isn't the case. We know, for instance, that in different vertebrates, the gut is constructed in very different ways during development.
In sharks, the gut develops from cells in the roof of the embryonic cavity. In lampreys, the gut develops from cells on the floor of the embryonic cavity. And in frogs, the gut develops from cells in both the roof and the floor.
So you have a homologous structure in vertebrates that is built in one way in a shark, in one way in a lamprey, in another way in frogs, and you've got these very different developmental pathways converging to the same structure. This is very hard to reconcile with Darwinian common descent.
These marine reptiles were built on much the same plan as you are.
I would say in the past 20 years of studying this problem that biology is now entering what can only be described as a revolution, because the evidence is so overwhelmingly against the conventional neo-Darwinian view.
Now, what about those other reptiles that flew in the air?